What's up, guys? In the last video we talked about structures, and while they're good for containing just variables, sometimes we need a little bit more than that. And with this here, I'm going to introduce the concept of classes and how it can help you solve problems. So why don't we take a look at this empty C++ file. So if I want to create a class, how should I start? Well, I should start with the class keyword and the name of the class that I want to create, which will be point3D. And I mean, what's really nice is that now when I go to main, I can just type point3D as is, and I can say, I don't know, just say P. Actually, we'll call this Q. Right. And when I'm done defining my class, this will be the valid way of doing it. I don't need to do any type def and do like class point3D as point3D as I need to do with structures. So already we're at an upgrade. But even though this is how we begin creating classes, when you end a class, it's actually exactly like structures. We need that closing curly brace and a semicolon. So why don't we start with the data that's contained with the class, namely the data members analogous to members in a structure. And here we have them. So I have X, Y, and Z. This time now I'm preceding them with underscores, so that way I know that these variables are going to be part of my class point3D. This is just my notation that I use. Some people have an underscore to the right of it rather than the left of the name of the variable. Some people don't even put underscores at all, and they have their own way of showing which variables are part of the class. So feel free for yourself to experiment with different ways. Don't let me stop you with just this format. But what's this private thing that's right here? Well, what this means is that this data here, while if it's part of a struct we consider it a member, now, because it's part of a class, we're going to call these attributes. So X, Y, and Z are attributes, meaning that they are data members that are part of the class. So here with private, what this means is that only the class instance itself can access these variables, meaning Q can access this itself inside of the definition of the class. And out here, when I have Q, I can't access its data members directly in main. That means when it's private, it means that this data can only be accessed within the definition of point3D. And why do we need to do this? Well, with structs, if I have a point, one of the great drawbacks is that if I have a point in three-dimensional space, and let's say I'm using it for graphics or something, I don't want to have any negative values for that data. But with a structure, you can just change that willy-nilly, and I want to have some more control over that. So with this statement here, this just means that not anyone can just edit these values directly or access them directly. So doing something like this won't be permitted because the data is private. We can't access it through Q in main. We can only access the private data inside the definition of the class. So this is private. Now we'll move on to public. And these are functions, and soon we will know, methods that anyone can use, including the class definition itself and variables in like main or other functions and things like that. So why don't we take a look at the first public function called the default unparameterized constructor. So here we have it. We have our first function that's going to be properly binded to the class. And actually I misspelled this. This should not be point. This should be point3D. And why should it be point3D? Hold on. This is the exact same name as the class. Well, that's the case because this function is a special function. This is called a constructor. And what a constructor is that it's a special function that is called at the creation of the class. It is called at the creation of the variable. So when I have q here I just declare q. Like any other variable that we've known so far, like structures, doubles, integers, etc., this should just contain uninitialized data. But that's not the case because it's a class. So just by doing this, I'm actually calling the default unparameterized constructor. This is called the default constructor because doing something like this is default behavior compared to what we know with C, and it's unparameterized because I'm not calling it like a function with parameters. And it's a constructor because this is called at the beginning of life for the class. More specifically, the variable q here. So if I run this code, when I create q, I'm going to be automatically calling this function exactly. But you know what? I want to have a way of creating my variable with default values. So you know what? Why don't I add the default parameterized constructor? And here we have it. Like the default constructor, it has the same name as the class. And that's how we know it's a constructor, is that it has the same name as the class. So any other functions that you see like this within a class for something that you may see in the future, if it has the same name as the class, it is a constructor of some form or another. But so far we're only seeing the unparameterized default constructor, and now we are seeing the parameterized default constructor. So with the unparameterized, I set all the attributes to one specific value. In reality, you can actually set this to whatever you want. You can set this to random numbers if you wanted to. I myself just wanted to set all these to 0, but here with the parameterized constructor, I'm going to take 3 values, x, y, and z, and I'm going to set them equal to each one of my attributes. So if this way is the way of calling the default unparameterized constructor, how can I call the default parameterized constructor? Well, you can call it like this. It is similar to how we call the unparameterized constructor, and actually this is similar to how we create variables in general, but we're kind of treating this like a function. It's like a mixture of creating a variable and declaring it and calling a function. So here what I'm doing is that I'm passing these 3 parameters to the declaration of the variable, which means that I'm going to be calling the default parameterized constructor. And what this will be doing is that it'll set the attributes of t to 8.3, 7.6, and 1.2. Whereas q, when I call the default unparameterized constructor, I will be setting it to 0, all 3 values. And actually, even if I wanted to, I can do something like 1, 2, 3, like so. So anytime that I create a variable like this, meaning the plain old declaration similar to C, all of them are going to have values of 1, 2, 3 for their x, y coordinates. There's one more type of constructor that I'd like to introduce to you, and that is the copy constructor. So if I have one point 3D that already exists, and I want to copy those values into another point 3D, well, how can I do it? Here is the constructor to show that behavior. And here we are. So because it is a constructor, it's going to have the same name as the class. But now the parameters, the input parameters are going to be different. While the default unparameterized constructor had no input values, and this point 3D has 3 input values, which are doubles, each belonging to each one of the attributes that belong to the class. Now, well, we have the same point, and there's my misspelling again. We have the same point data type that's going to be the input of our copy constructor. And again, so this is neat because I'm able to use a reference, which means I get to have the exact variable that I'm copying. I'm not making a copy, and I'm making it a const, so that way if by accident I try to change one of the values of p, which I don't want to do because I just want to make a copy, I won't do so. So what I do is as simple as copying the values that belong to p into my current point 3D. So what does this mean? So if I go down here and I'd like to call the copy constructor, it would look like this. So now the input is different compared to T. So when I call E with its input T, well, E and the value and the attributes that are associated with E here are these. And when I call the copy constructor, T becomes P. So I'm actually copying T dot underscore X into E dot underscore X, T dot underscore Y into E dot underscore Y, and T dot underscore Z into E dot underscore Z. And this will allow me to take a copy of my class. The last thing I want to cover is the destructor. And in this example, it's not exactly useful to really talk about this, but in future examples, it'll be very important. So why don't we quickly cover it? And here we have it. So what makes a destructor is that you're going to put a little tilde in front of it, which on your keyboard, it should be by your 1 key right under the escape, and then you'll have the name of the class. So if you have the tilde and the name of the class, it's your destructor. So while these three above, the default parameterized constructor, the default parameterized constructor, and the copy constructor, while these three are called at the beginning of life for the variable, the destructor is called at the end of life for the variable. This is done to clean up any data they may have generated and want to get rid of. And this is especially important when you have data dealing with dynamic memory allocation, or let's say you have a class that has a network connection. When your variable is done doing all the networking stuff that it needs to do, it obviously needs to disconnect from the internet before the variable gets destroyed. You don't want some hanging zombie connection, in your variable that connects to the internet. So that's the main role of the destructor. It is called at the end of life for the variable. Lastly, I want to say is that these three constructors that I've shown you guys, they are not modern C++. This is old C++, which there's nothing wrong with that. However, with newer standards, they're actually coming up with methods of copying variables and initializing variables faster by doing it the modern way rather than this old way. So I'll show you the new way now. And here we have the modern code. So what is the big difference between what I've just shown and what's new here? Well, instead of having the attributes have their values be given in the body of each one of the constructors, now I have a colon, and then I have each one of the attributes, and they are initialized with curly braces. And the same thing is done here. I have the colon as well as the attributes, and the curly braces. Here I have some constant values that I want to assign to my attributes, which are all zeros. Here I have the respective variables where I have x with underscore x, y with underscore y, and z with underscore z. And then here with the copy constructor, I have the same colon, but now I'm using p dot underscore x to go with x, and so on. So I use the attributes of my input p to initialize the attributes of x, y, and z of the class that's calling this copy constructor. And it turns out when you do it this way, under the hood, it works just a little bit faster than the other way, the old way that I just shown. But this about wraps it up for classes. But this about wraps it up for this video, where we introduce the concept of a constructor and a destructor. And in the next video, we're going to talk about special functions called methods. And we're going to talk about a specific subset of methods that, depending on the class that you create, could be, default or standard. You'll add these set methods and get methods as appropriate for your class. But before you guys can make that decision, I need to show you that. So I'll see you there.